let's review how to simplify rational expressions. The word rational simply means there is a ratio involved, which means it's going to look like a fraction. So the one thing you have to always keep in mind is if you have a fraction, there is one value the denominator can never equal because it is meaningless. It would make your fraction undefined. That occurs when your denominator would equal 0. So if you are asked to find any values that would make a rational expression undefined, it simply means set that denominator equal to 0. Whatever you come up with, those are the values of x you cannot use. It would make it undefined. Now, if your denominator can factor, you'd want to factor it first and then set each factor equal to 0 and solve. But in this first example, we have x plus 7 in the denominator. It does not factor. All I have to do is set x plus 7 not equal to 0, which means x cannot equal negative 7. If I subtract 7 from each side, that will tell me how to get x by itself and what value of x I can't use. So any other value of x would be fine in this problem. If you look at number 2 and check your denominator, it will factor. Now be very careful that you factor correctly. Remember, you're always to look first for a greatest common factor. This one has a GCF of 4x. So if I factor that out, in parentheses, I'm going to have x minus 4. And I would take that and set it so that it cannot equal 0. That would simply mean 4x cannot equal 0, and x minus 4 cannot equal 0. Therefore, x cannot equal 0, or if I add 4 to each side, that would mean x cannot equal a positive 4. Either one of those values would give me a denominator of 0, and I can't use them. You might notice as well, when we factored this denominator, even though it has a common factor with the numerator, we cannot cancel it out. At this point, if all you're looking for is what would make your fraction undefined, you don't care what's in the numerator. The numerator's fine. It can be anything. We only need to discover what values would create a problem for us in the denominator. So the first one had one possible value we couldn't use. The second one had 2. All right. If we look at the next set of questions, it says write each rational expression in lowest terms. Assume that no values of any variable make any denominator 0. In other words, they're just reminding you that you are already assuming you can't have 0 in the denominator, so you don't have to worry about coming up with something that might possibly not work in the original. So this is telling you don't worry about that. You simply want to reduce it to lowest terms. Now number 3 is what we would call a monomial expression. There are no addition or subtraction signs anywhere. All of the numerator is simply factors being multiplied together. Same is true for the denominator. When that occurs, we simply look for common factors and reduce down. So look at the numbers separately. I have a 15 in the numerator, a negative 24 in the denominator. The greatest common factor for that would be 3. 3 will go into each of those numbers evenly. So if I divide 3 into 15, it's going to go 5 times. If I divide 3 into negative 24, it would go a negative 8 times. Again, the negative sign really doesn't matter where you locate it. It can stay in the denominator, you can move it to the numerator, or you could put it in front of the entire fraction if you like. As long as there's only one negative sign, you're good. Now, when I look at the variables, I'm going to reduce down based on the exponents. If I look at the a, I have an a to the first power in the numerator and an a to the first power in the denominator. Any number divided by itself reduces down to 1. So those a's are going to cancel out. I won't have any a's in my simplified answer. If I look at the b's, I have b to the third power in the numerator, b to the second on the bottom. Where do I have the most b's? In the top. So if I subtract those numerators, the exponents, I'm sorry, I should say, if I subtract those exponents for the b's, 3 minus 2 is 1. That's going to be the exponent that belongs with the b, and it will go in the location where I had the most b's to begin with. So it's going to be in the numerator. So I'm going to have a b in the numerator. No b's will remain in the denominator. Do the same thing for the c's. I have c to the 9th divided by c to the 10th. There are more c's on the bottom than there are in the top. 10 minus 9 is 1. So that's going to tell me that I have c to the first power in the denominator. And this will simply reduce down to be 5b divided by negative 8c. And that's all you do when they are monomials. Now notice on 4, this example, they're not monomials. I see some minus signs here. I have more than one term in the numerator and I have more than one term in the denominator. So I have to factor first before I can reduce down. I can only reduce down things that are being multiplied together, things that are factors. So if I look at the numerator, I have a common factor of 9. And if I factor that out, I'm going to end up with x squared minus x minus 12 in parentheses. Now I know that's going to factor more, and I'll take care of it in a minute. The denominator is a little easier to factor. All that I have here is a GCF of 2, and that will give me x minus 4 in parentheses. My denominator is completely factored. My numerator is not. So let's work a little more on that numerator. This is quadratic. So I am looking for, because my a value is 1 in front of the x squared, I need a pair of numbers that would multiply to give me negative 12, add to give me a negative 1. The pair I'm going to need is a negative 4 and a positive 3. So x minus 4 times x plus 3 is how x squared minus x minus 12 will factor. Again, I could use FOIL or the box, multiply those back together to double check, and I would see that it is factored correctly. I still have 2 times x minus 4 in my denominator. Now, the same principle applies that we used on the previous problem. I'm looking for common factors that I can reduce down or cancel out. And what I notice here is I have 2 parentheses that match exactly. When you have factored and you have more than one term in a parentheses, you can only reduce down or cancel out if they match exactly. So these x minus 4s will cancel out. X minus 4 divided by an x minus 4 will reduce down to be 1. My 9 and my 2 do not have any common factors. If, for example, that instead of a 9, if that had been an 8, the 8 and the 2 would have reduced down. I just happen to have a pair that will not reduce more. And I can't do anything with that x plus 3 because it could only be canceled out if there was another identical x plus 3 as a factor in the denominator, and there is not. So my final reduced answer, and by the way, you can still leave it in factored form, would be 9 times x plus 3 in the numerator divided by 2 in the denominator. Okay, in addition to simplifying individual rational expressions, we sometimes will have 2 rational expressions that either have to be multiplied or divided. We still are going to follow the same pattern that we just did, but it means we have 2 fractions that, if possible, need to be factored first because I can't reduce or cancel anything until everything's been factored. And if there are plus signs or minus signs, they are in a parentheses. So when I look at number 5, these are monomials. I see no plus signs, no minus signs, so I'm just going to begin reducing what common factors I have. I see a 3 in the denominator, a 9 in the numerator. 3 will go into each of those evenly. So 3 goes into 3 one time, goes into 9 3 times. I've done everything I can with the numbers in this problem. So if I were to multiply that straight across, I'm going to get a 24 in the numerator because 8 times 3 is 24. The only number in the denominator is a 1. I won't worry about it right now. I don't need to write down a 1. As I look at the variables, I have a p squared in the numerator and a p in the denominator. Remember, when you don't see an exponent, the exponent is actually a 1. So there are more p's in the numerator than there are in the denominator. So this 1p in the denominator will take out one of the p's in the numerator, leaving p in the numerator. Do the same thing for the q's. But this time I notice I have more q's on bottom than I have on top. So if I reduce down this q with one of these q's, I'm going to end up with 24p divided by q as my simplified expression. That's all there is to it. Now when you look at 6, there's a little more involved. We do have numerators and denominators that factor everywhere. So that's what we want to do, is take our time and factor first. If I look at the numerator for the fraction on the left, it's x squared plus 7x plus 10. That would be an AC method for factoring. I've checked, I don't have a common factor, but I do have a quadratic, and my A value is 1. So a pair of numbers that multiplies to give me 10, but adds to give me 7, would be 5 and 2, and I can factor this into x plus 5 times x plus 2. Over. If I look at that denominator, 3x plus 6, the only thing I have is a GCF of 3. That would leave me x plus 2 in parentheses. Times, let's go to the second fraction. My GCF is going to be 6 in the numerator. So I factor out a 6, and I will have x minus 1 in parentheses. My denominator is another quadratic. I do not have a GCF. My A value is 1. So I'm looking for a pair of numbers that multiplies to give me negative 15, adds to give me positive 2. That's going to end up being x plus 5 times x minus 3. And at this point, everything is factored. Notice the only plus signs, minus signs are showing up inside parentheses. And I have this, the x plus 5 times the x plus 2 times the 6 times the x minus 1 are all in the numerator. In the denominator, it's 3 times x plus 2 times x plus 5 times x minus 3. So I'm ready to start reducing or canceling common factors. And I will notice, to me this is the fun part, I have an x plus 2 in the numerator and an x plus 2 in the denominator. I can cancel those out. I also see an x plus 5 in the numerator and an x plus 5 in the denominator. Notice it does not matter if they're in the same fraction or they're in different fractions. As long as they're being multiplied together, I just have to have a common factor from the numerator match a common factor from the denominator if I'm going to cancel. Now, I don't have any other parentheses that match. What I do have is a 6 in the numerator and a 3 in the denominator. Those are just numbers. I just reduce them down like I would any other fraction. 3 is the common factor, so 3 goes into 3 once. 3 goes into 6 2 times. And what I am left with is 2 times x minus 1 in parentheses over x minus 3 in the denominator. And it doesn't matter if you put the parentheses around the x minus 3 or if you leave it off. Either way is acceptable. But be very, very careful here. You cannot cancel out these x's. Remember, when something's in parentheses, the entire parentheses has to match completely before you can cancel or reduce down. So when you get to this point, you are finished. There is nothing more you can do to simplify. The only little extra step you need to recall if you are dividing is that division of fractions means that you multiply by the reciprocal of the second fraction. So we never do anything to the first fraction, but we want to take the second fraction and we want to flip it and multiply. You may have learned something like leave, change, flip when you were in middle school and you first learned how to do this. Again, 7 is simply a monomial divided by a monomial. We have nothing to factor. We just start reducing down. And what I see is that 2 is a common factor between 2 and 8. So that's going to reduce down to a 1. 2 goes into 8 4 times in the numerator. I can do the same thing with the 5 and the 10. 5 is a common factor. I'm going to get 5 goes into 5 1 time. 5 goes into 10 2 times. Now before you stop, look at what you now have. I have a 4 on top and a 2 on bottom. There is still a common factor, so I can reduce one more time. 2 will go into 2 one time. 2 will go into 4 2 times. And I know this can sometimes get a little messy, so at this point you may want to stop and say, okay, as far as number goes, I'm left with a 2 on the top and I only have 1s on the bottom. So I'm going to go ahead and write my 2 down for my simplified answer. And now I'll take care of the variables. I have an a squared in the numerator and an a in the denominator. When I reduce that down, that's going to leave me an a in the numerator. I have a b in the numerator and a b squared in the denominator. More on the bottom than in the top. That means when I reduce down, I have a b in the denominator, and that is my simplified answer, 2a divided by b. Last one, we see we have another division problem, and it is one that involves some factoring. So the very first step is leave that first fraction just like it is, so I'm just simply going to recopy it, but I'm going to change it to multiplication and now flip the second fraction. So I have y minus 3 in the numerator, y squared minus 4y minus 5 in the denominator. And at this point, I'm pretty much back to where I was on example problem number 6. I just need to factor, and then I can cancel or reduce and simplify. So if I factor the numerator on the left side, pair of numbers multiplies to give me 3, adds to give me 4, would be positive 3, positive 1. So I'm going to factor that into y plus 3 times y plus 1. Notice my denominator on this one doesn't factor. It's just y plus 3. Times, if I move to the fraction on the left, that numerator does not factor, but the denominator will. So I need a pair of numbers that multiplies to give me a negative 5, adds to give me a negative 4. That means I need y minus 5 times y plus 1. And now that everything is factored, I simply look for what I can reduce and simplify. Remember, it has to match exactly if you see plus signs or minus signs. So this y plus 3 on top will take out the y plus 3 on bottom. I have a y plus 1 on top that will take out a y plus 1 on bottom. And what I am left with is y minus 3 on top over y minus 5 on bottom. Now make sure you do not attempt to cancel out those y's, because there are minus signs involved. You cannot take out pieces. These would have to match exactly, and they don't. And that's all you have to do to simplify rational expressions.